Hey everybody, this is Gregory from DApp University. So welcome back to this mini-series where I'm showing you how to build a decentralized file upload DApp with IPFS and Ethereum smart contracts. So in the previous videos, I've kind of showed you how to get started with this. So be sure to check out the early videos in this playlist if you haven't already. So yeah, what we're building is, an app, a DApp that allows you to, upload files to IPFS, upload images in particular, and then store a reference to those images on the Ethereum blockchain with smart contracts. So let's take a look at, where we left off and kind of see where we're going to go from there. In the last video, we got to the point where I could, pick a image file and submit this to IPFS, and we would see the result on our app here. So this image file is actually located on IPFS. You can see the IPFS hash here that came back. So now what we want to do is actually continue on and store this value on the blockchain, because if we refresh this page, this completely goes away. Right now we're just storing the IPFS hash on the client side. We're storing it with React.js and a component in the component state. And what we want to do is actually store it on the blockchain so that when we refresh the page, it's still there. So let's get started doing that. What we're going to do is, go inside this onSubmit handler, and we're going to wire this up to write this value to the blockchain after we write it to IPFS. But before we do that, let's go over a couple things. In the previous videos, I just commented this out, and we'll need to actually update this. So really quickly, if you haven't checked out the previous videos, I've got this React component that came for free with our React Truffle box. Truffle is a framework for building decentralized applications, and Truffle boxes are, ways of getting some boilerplate code for free. So a lot of this code was written for free whenever we opened up the Truffle box, and we're kind of modifying it for our purposes to show you how you can build something like this quickly. So we don't have to just go through the pain of doing all this ourselves. So what we want to do is update this initializer. So React has these, callbacks that get fired based on the component lifecycle, right? So these can get pretty complicated pretty fast, but just take my word for it. Component will mount, fires kind of somewhere around the time that the component is rendered. You can read more about those on the React.js documentation. That's not really the purpose of this tutorial. But essentially, React, whenever render is called, it lays out the HTML on the page. And it's got some callbacks that say, basically after this constructor fires and before render happens, or after render, or et cetera, et cetera. These are basically just some magic functions that get called whenever events like that happen. So essentially, this is a magic function inside React that's going to get called when we know that the component is going to mount. And what's going to happen inside here? So essentially, we're going to get Web3, and we're going to instantiate it, and then we're going to instantiate the contracts. So if you haven't checked out my other tutorials where I work with Web3 and Truffle contracts, smart contracts on Ethereum, be sure to check those out. They're pretty much my most popular videos on the YouTube channel at the moment, so you can find those pretty easily. I'll probably also have some links down in the description below. I will go over, Web3 and, Truffle and smart contracts in more detail in those videos. But I'll say a couple quick words here. So Get Web3 is a utility that came for free with this Truffle box. We're importing it here. We have utils get Web3. And so Web3 is a library that turns your client-side applications into a client-side application that can talk to the blockchain. It's basically a blockchain-enabled client-side app, or a client-side DApp at that point. And, Web3 is going to allow us to talk to smart contracts directly, to, fetch smart contracts, data, and write data to the blockchain. And I'm not going to go over all this complex stuff at the moment. Just take my word for it and check out my previous tutorials to learn more about how Web3 works. So let's go back to our app.css file, app.js file, and take a look. So we're instantiating Web3. Essentially what's going to happen is, Web3 relies upon a provider, and that provider is an Ethereum provider. I'm going to reject this. That Ethereum provider is going to be given to us by MetaMask. So this is another dependency that you can learn about in my previous videos. MetaMask is a plugin for Chrome that allows your web browser to turn into a blockchain browser. A web browser like Chrome can't talk to the blockchain without this kind of plugin. And I've imported an account from Ganache into MetaMask, and that's another thing. You want to make sure you've got Ganache running before you continue on with this tutorial. And check out the previous videos where I showed you how to launch Ganache. And if you don't have an account in MetaMask already, you can copy the private key out of Ganache here, and you can go. Oops, I didn't actually mean to close that. Let's open Ganache back up. You can copy that account out of Ganache and add it back to MetaMask. So I accidentally closed Ganache. But if you're going to do that, you would go basically to MetaMask and you would import an account and add it there. So I accidentally closed Ganache. My bad. If I'm going to do that, I lost the state of my contracts. So I'll have to go back here, new Truffle, migrate, -- reset. That's because, we basically shut down our blockchain and lost the state of all our contracts. All right, so let's minimize Ganache and go back to our project. I just wanted to cover some of those preliminary topics so that we understood what's going on here. So yeah, inside this component will mount, we set up Web3, and whenever Web3 gets set up, we're going to instantiate the contract, and that's this function here. What we're going to do is use the Truffle contract library. Like I said, I'm not going to go too in depth into this. You can check out my previous tutorials if you want to learn more about that. Where we'll basically create a JavaScript representation of the smart contract that's deployed to the blockchain, and we're going to set it as a variable here. So instead of saying this is a local variable, I'm gonna clear that out and do it like this. Yeah, so instead of declaring this as a local variable here, I actually want to write it to the component. So we'll do it inside here. So basically this is saying get the current account that we're connected to the blockchain with. That's going to be, oh, this is broken. That's okay. That's going to be, this account here that we're connected to with MetaMask. And I'm going to assign the current account to the component state like this. So essentially what's going to happen is this is fetching the account that we're connected with. All right, once that's done, this is an asynchronous call. We're going to get a deployed instance of the smart contract. This is just going to be a JavaScript representation of the smart contract that allows us to access it. And we're going to assign an instance of this variable. This variable was defined here, so I'm going to do this dot simple storage instance. I'm going to write this to the component so we have access to it later down the chain. And I'm also going to take this account, these accounts that were passed in. I'm going to get the first one. I'm going to say this dot set state I'm actually going to update the component state and say account is equal accounts 0. It'll be the first account in this list since this is a 0-based index array. And I'll set a default value for the account here. Say account. I'm just going to call it null. You can do this a couple different ways. You can do 0x0 or empty string, but I'm just going to do null. So this is going to keep track of basically, the current account. This is going to be sort of like, a current user function that you might see on a centralized web application. All right, so instead of doing this set, I don't really want to set a value here. This is just the boilerplate code, so let's kill these lines here. Let's actually get the value from the blockchain. So for now, this is going to be blank because we haven't actually written anything to the blockchain yet, which is fine. I'm actually just going to leave this line as is. And here, this is going to be the IPFS hash, actually. Let's say results IPFS hash. That's what's going to get returned from this, get function from our smart contract. All right. This is the smart contract we're calling get. And, this is an asynchronous call, so we have to use a promise chain to get the value back. And it's going to return an IPFS hash. And I'm actually going to store that IPFS hash like this in state. So in ES6, this is the same thing as doing, that's the same thing as doing this. It allows you to basically pass an object where the key is the same name as the value. It's just a shortcut for doing that quickly. So set state, let's say, so IPFS hash is already set here. So I believe you still got reference to the storage value somewhere else. If not, I'm just going to clear it out because we don't need it anymore. All we want to see is the IPFS hash here. All right. And we've already kind of, dealt with this IPFS hash here. We set it on the submit, set state, IPFS hash, result 0 hash. And that's what we're going to do whenever we load this page up. We want to say, hey, was this value set to the blockchain? If it was, let's read it out of the blockchain and set it to our, component state so that we can read that value whenever we refresh the page. So let's just save that, go back to our browser, and see what the problem is. All right, so simple storage instance is defined, but not defined. All right, so I got a little problem here. All right, so basically I didn't call this. So we've been writing this instance of simple storage to the component, so we want to read it that same way. So I'll refresh that and go back to the browser and see. All right. Okay, so we'll see this IPFS error here. It's bad request. That's okay for now. Since this is just a prototype, this is just a mock-up. We can optimize this later. Essentially what this is trying to do is read this value, this.state.ipfs hash down here with this IPFS URL, and we're passing in an empty string because that's the default value. Well, actually, really, we're passing in whatever came back from the contract in this case. So it's nothing, and IPFS is giving us an error because it doesn't know how to find that file, which is really what we expect. So I'm going to save that and go back to the page, refresh. All right, so now what we want to do is wire this form up to not only write to IPFS, but also write to the blockchain with our smart contract. And now that we've actually wired up the smart contract to store the value and read the value, we want to store the value down here. So I'm going to update this on submit. And I'm kind of just hack this out. Like I said, I'm live coding this, so you can probably do this a little more cleaner. I'm not necessarily going to spend a ton of time refactoring this. I just wanted to show you how to get started doing this. So what we'll do is get the instance of the contract, this simple storage instance, right? This is how we set this up here. All right, and we're going to read that and say set. That's the function where we're actually going to write the data to the blockchain. And, this is the hash that we were doing in set state. So I'm going to copy this and paste it in here. So we actually want to put that IPFS hash inside this set function. All right. We also want to pass in some function metadata. You can kind of check out my previous tutorials to learn more about that. Basically, Solidity functions accept arguments, but they also select metadata that tell you a variety of things. This metadata is a message in Solidity, and it tells you who is calling this function, which account is like trying to create a transaction on the blockchain. So we do that with from, and we say this.state.account, right? Which is what I set up here, right? So this is sort of the current user of the application. And this is going to be an asynchronous call, so I need to use a promise and say result. All right. And here is where I'm going to say return this simple storage instance get call this state account. And I'll tell you why I'm doing this, because I want to write this value to the blockchain and then actually read this value from the blockchain to basically ensure that it worked. So value from the contract to prove it worked. All right, so that's going to return a promise, which I can continue executing on this chain and say IPFS hash. Actually, want to get the hash back, and we want to update the result. And I'll do that like this. Let's console log IPFS hash, and we'll say IPFS hash, and we'll do, actually let's do this. This set state IPFS hash. Remember, this is just a shortcut. And let's do this state IPFS hash. Okay. So let's kill these lines and do that. All right. So let's go over what I just did here. So on submit, we're going to add the file to IPFS. And whenever it's done, we're going to get the result. Actually, let's not call this result. Let's call this R. To avoid any naming conflicts. All right, so simple storage instance set result 0 hash. That's going to be the hash from IPFS. This is actually going to write this value to the smart contract. And we're going to tell it that it's this account that we are connected to with MetaMask. That's who's signing this transaction. And this is an asynchronous call, so we'll use a promise. And whenever that's done, we're going to actually retrieve the value of the IPFS hash from the blockchain. And whenever we have that value back, we're going to update the state with the value that was set to the blockchain. So state is actually only going to get updated once all this is successful. And by doing that, we'll know that every link in the process happened correctly. IPFS was updated and the blockchain was updated. And like I said earlier, with React, whenever we update the state, this component's going to get re-rendered, and we'll see the image that we uploaded displayed here. All right, so that's a lot of changes. Let's hope it actually works. Let's go back to our app here and just double check, refresh. And I'm going to choose a file. Let's choose our logo and open and submit. All right, so this is a new thing. So MetaMask is popping up saying, hey, you have to pay to create this transaction, which is what we expect, because transactions written to the Ethereum blockchain cost gas. So we got to pay a small amount to submit this. So I'm gonna click submit, and womp womp, we have an error. So this is a known issue with MetaMask. Basically, I'm gonna have to change, like Ganache crashed, or I closed Ganache, and I have to change networks. So let's do that. Go back to the main network, and then go to custom RPC. Sorry, HTTP. I believe, let's just double check to make sure I know which port Ganache is running on. I actually like leaving these hiccups on camera because it shows you the kinds of things you might encounter when developing decentralized applications with the technology as it is. Well, let's just save this. All right, private network. Okay. All right, so let's refresh. I hope I don't have to restart Chrome. I don't think I do. All right, submit. Wait for MetaMask to pop up and submit. And all right, let me pause the video really fast and try to work this out. Give me just 1 second. All right, so I had to kind of debug MetaMask there for a second. But yeah, got MetaMask working again. Yeah, you might have to fool around with this a little bit if you get stuck. But yeah, so what we're going to do is now try to save this value to the blockchain. And I'm going to actually back out of what I said a second ago. Let's just do this. So let's simplify this a little bit for the sake of this tutorial and just say, let's just update the state here. Let's not wait for this to return. Let's just do it like this. Let's say this. Let's just return. This.set state IPFS hash, and we'll say result. It's gonna be just the same value. So we could optimize this, but for now let's just keep things simple. And we will console log this.state IPFS hash. Let's see if this works. All right. Let's see here. Hope that's okay. We'll try that in a minute. This.set state. Okay, yeah, let's try it. Let's try to upload an image and see how far we get. It might have an error, it might work. Let's find out. And I'm going to pull this down so you can see and submit. And we'll have to sign the transaction with MetaMask. Okay, set. Looks like I had an issue there. App.js line 87. This.state account. All right, let's see what the error here is. Okay, so the error is saying that it doesn't know what set is in the contract. And if we look at our initial error that I kind of just glanced over a second ago, the network request failed because Ganache crashed. So I really hope this doesn't make us reset MetaMask again, because that takes a long time. Let's just relaunch Ganache. You'll see it open again. All right, and because we relaunched Ganache, we'll have to remigrate the contracts like this. Truffle migrate, -- reset. All right, so our contracts are redeployed. It's a little bit of a headache. If anyone from Truffle or MetaMask is watching, then feel free to give me some pointers. All right, so hopefully I won't have to reset MetaMask again. All right, so let's submit. And I do have to reset MetaMask again because Ganache crashed. So I'm going to pause the video. Give me 1 second, guys. All right, so I got the issues worked out with MetaMask again. My apologies for having to pause the video, but that's sort of the nature of the beast at this phase in the game. So yeah, I'm just gonna refresh this, and yeah, let's take a look at the code we did. Right, so we're writing this to the blockchain, and we're updating the IPFS hash to the component state. So we should be able to choose a file like this, and whenever we upload this and click submit, it will write to IPFS and store the value on the blockchain. So let's give it a try. See the MetaMask confirmation pop up, and I'm going to click submit, and boom, it appears that our code has executed successfully. We've got the file back on IPFS, like we saw in the previous video where we just kind of wired it up the first time. But now let's see if we can refresh the page. Let's see if it's actually written to the blockchain. Boom. So our page has refreshed, and we have read the value again from the blockchain. As you can see, we are reading this whenever we instantiate the contract. We're getting the value from the storage contract, and we're setting the state. We're setting the IPFS hash to this component state, and we're reading that value out here whenever we render the image out on the page. So we know that this value is coming back from the blockchain. We can even go to our Truffle console, say Truffle console. We can find the instance of our contract. So it'd be simple storage. Copy this. Say simple storage deployed, and then pass a function, and then we'll say app equals I. We'll say app get, and let's say then function I. And we'll say IPFS hash equals, let's just say value. IPFS hash equals value. All right. IPFS hash. Boom. And that is the proof, ladies and gentlemen, that we have stored the IPFS hash in the smart contract. Again, this is the Truffle console that you can use to interact with your smart contracts in a JavaScript runtime and environment directly. You can check out my previous videos where I show you how to use that Truffle console more. But yeah, we know for a fact that this value is getting written to the blockchain. And there you have it. You have a decentralized image uploading DApp that works with IPFS and Ethereum, with Ethereum smart contracts. So I'm probably going to wrap up the video at this point. This is really all I had planned for the mini-series. I may release some more videos in this if you all would like to see what you can do with IPFS and Ethereum. So be sure to leave a comment down in the comment section below if you want to see things like, running your own IPFS node locally, like you would run Geth. Yeah, just let me know, and maybe I'll add some more videos to this series. So be sure to subscribe to the channel to see more videos like that. I'm going to exit the console here, and let's say I'm going to commit all these changes. We'll say, wires up, file, uploads. And I'm going to go ahead and put this code on GitHub, so I'll leave a link down to that in the description below. You can download this code yourself and follow along. In case you get stuck, you can have that code as a reference. So yeah, be sure to subscribe to the channel and let me know if you'd like to see more videos about how you can integrate file uploads into your decentralized applications. This should get you started, kind of showing how to do something like this. You could potentially do things besides images. You could do PDF documents. You could actually encrypt the PDF documents so that they are stored securely. You could do some sort of form of asymmetric encryption, where you pass a public key to another user and they would use their private key to decrypt the message. So we could potentially explore something like that. So yeah, be sure to subscribe to the channel. And until next time, thanks for watching Dapp University.